So hi everybody. So in this video we will be discussing about center of mass. So I am Dr. A.L. Subramaniam, working as associate professor in physics with SRM Madurai College for Engineering and Technology. So in this video we will be discussing about center of mass with respect to the following contents. First we will go through the definition of center of mass. Then we will take up some examples to understand the concept of center of mass better. Then we will see what is the formula for center of mass for two particle systems, for many particle systems, and we will also go through one numerical to get a better understanding of the center of mass. So what is the definition of center of mass? So center of mass is that point in an object where the entire mass of the body is supposed to be concentrated. So in other words, I can imagine that I can replace the entire body by a single particle. And if I describe the motion of this particle, we would have described the motion of the body. So that particular point where the entire mass is supposed to be concentrated and which is used for describing the motion of the body is called its center of mass. There are some other names for center of mass. It's also called as the balancing point. For example, we can hold a notebook with a single finger by placing the notebook at some point, and that point is the center of mass. So let us take some examples. For a triangle, the point of intersection of the medians, that is the centroid, represents the center of mass. For a circle, it is exactly at the geometrical center. For a square, it is at the intersection of the diagonals. For a rectangle also, it is at the intersection of the diagonals. In all these cases, we see that the center of mass is lying inside the body. But there are some special cases where the center of mass can lie outside the body. For example, we have an L-shaped strip, then the center of mass will be lying along this line where the entire mass would have been acted. Now how to find the center of mass of two particle systems? Suppose I have two particles of mass m1 and m2 separated by a distance x1 and x2 from the origin. Then this point COM is the center of mass. So the x coordinate for the center of mass is just given by the expression m1 into x1 plus m2 into x2 by m1 plus m2. So if the bodies were along the y-axis, then it would have been ycm equal to m1y1 plus m2y2 by m1 plus m2. So this is the formula to find the center of mass of two particles. Now let us take a simple problem to find out the center of mass of two particle systems. You have two point masses 8 kg and 4 kg, which are 5 meter and 10 meter from the origin on the x-axis. So the two masses are 8 kg and 4 kg. So m1 is 8 kg, m2 is 4 kg. The first particle is at a distance 5 meter, x1 is 5 meter, and second particle is at a distance 10 meter. So x2 equal to 10 meter. So we have m1 equal to 8 kg, m2 equal to 4 kg, x1 equal to 5 meter, x2 equal to 10 meter. So the formula for a two particle system is m1x1 plus m2x2 by m1 plus m2. So if I substitute the values, we'll get 6.66. So if I have a large number of particles, Then how to find the center of mass? Suppose we have particle m1, m2, m3, mn by, then in that case the center of mass will be m1 into d1. The first particle m1 into the distance d1 from the origin, the second particle m2 into the distance d2 from origin, the third particle m3 into distance d3 from origin, and so on. So the numerator can be written as m1 d1 plus m2 d2 plus m3 d3. I can also write it as summation over I equal to 1 to n mi di by the total mass of the system. So indirectly the center of mass is the first moment of the system by the total mass of the system. So if we have two particles m1x1 plus m2x2 by m1 plus m2, if I have large number of particles, then summation over I equal to 1 to n mixi by summation. So how to find the center of mass of continuous bodies? So we already saw for discrete bodies that it is summation x into the mass by the total mass. Now suppose I want to find for a continuous body like a rod, a thin rod, then we have to use the method of integrals. So according to the integral method, the x coordinate of the center of mass is integral x dm by integral dm. So integral dm will give me the entire mass, capital M mass of the rod, and integral x dm is in the numerator. So let us take a simple example for a one-dimensional body. We have to find the center of mass of a uniform thin rod of length L. So since its mass is distributed along one dimension, we can define the linear density lambda, which is the mass per unit length. So the total mass of the rod is lambda into L. Now if I take a small portion of the rod, we get a small mass dm, which can be given by lambda into dl. And because it is distributed on x-axis, I am writing it as lambda into dx. So now the center of mass is 1 by capital M integral x dm, where dm is the mass of a small portion of the rod we have considered, which can be written as lambda dx. So I can pull lambda outside the integral. So lambda by m, the total length of the rod can be from 0 to L. So 0 to L x dx. Now we know that integral x dx is x square by 2. So if I substitute the limit, I will get L square by 2 with lambda by m outside. Again we can replace the mass as lambda into L. So then we can do some calculation. Lambda and lambda will cancel, L and L will cancel. I get L by 2, which means that the center of mass of a uniform rod is exactly at the center, which is total mass of the system. So thank you all for watching this video.